Good afternoon to my dear students. We are going to see about linked list in data structures. First, we have to know what is data structure. The way we store the data in the memory is called as data structure. So, we have the outline of what we are going to see in this course. What are the different categories of data structures, and we are going to see here in particular about the linked list, its definition, representation, operation, implementation, application and types of linked list. So, first I told you that data structure is the way we store. So, there are two type of data structures. We have linear and non-linear. So, continuously when we store without the memory, it is called as linear, and wherever we find some memory and we store it without any particular order, it is called as non-linear. So, linear data structures, we have stack, we have queue, we have linked list, and in non-linear we have graph and tree. So, we are going to see the linear data structure linked list today. So, first, what is the definition for linked list? It is a linear collection of data elements stored continuing in an ordered manner. So, the representation is this way. It is represented where it has two things. So, this is called as a node, where it has the data part and the link part, and the data will have the value that we want to store, and the link will have the address of the next location where the next value is present. That is what given here. Now, what are all the operations available in linked list? So, we have insertion, we have deletion, we have traversing and searching. What is insertion? Adding a new node, creating a new node and adding a new value, it is called as insertion. Deletion is removing an element to be that is we don't want in the list, that is called as deletion. Traversing is traveling through the elements, or that is the linked list, and finding out any. It is used for either for insertion or deletion or even for finding the element. Searching is actually finding the first occurrence. So, if you have more occurrences of data in the list, then where the first occurrence of the data is available, it is used by this searching operation. So, how insertion is done? So, insertion is actually done at three positions: at the beginning of the list, at the middle of the list and at the end of the list. So, we will see how. So, this is before the insertion. So, here say for example, this is the list where I have the start position which will be pointing to the first node of the linked list. It will have the address of that, and the first node will have a link part which will be pointing to the next node, like that it keeps on going, and the last node will have the link as X to tell that it is the end of the linked list. So, here I want to insert at the beginning. So, how it is performed, we will check it out. So, what happens is, previously it was the start pointer was having the address of the first node, but I want the new node n to be inserted here. So, how it is performed now? So, the start will have the address of, instead of having the address of first node, it will have the address of node n, and the node n's link will be pointing to the first node. So, this is how the new node is inserted at the beginning. So, this is actually done with the coding as this. So, start is equal to the node n. So, that means that node n address will be stored in start, and node n's link will be equal to the first node. Next operation, we have insertion at the middle of the linked list. So, I want to insert at the middle, say between the node A and node B, I want to insert here. So, how it is performed, that we will see. So, here I have the node n, where it is to be inserted between this node and this node B. So, the link between, that is the address of node B, will be there in the link of node A, which has to be removed now. So, what will happen is, the address of the new node will be stored in node A, and the link part of node n, that is the new node, will have the address of node B. That is, the content whatever is previously available in node A will be stored in the link part of node n, and the new node's address will be stored here. This is how it is inserted at the middle. So, the operation done is this: node n's link will be equal to node A's link, what is already previously it was having, and node A's link will be equal to the new node. So, insertion at the end, how to perform this? So, that means at the last node, after the last node I want to have it. So, how to perform that? So, here we can see that this node B, after this node B I have the last node, and after the last node I want to get inserted. So, I told you already that the last node will have the link part as X to tell that is end of the node. So, end of the list. So, to make that not to be the end of the list, what we are going to do is we are going to have the instead of this null this of x, we are going to have the node n's address over stored in the last node, and the last new node what we are going to add, that is the new node n, will have the link part as x to tell that that is the end of the linked list. So this is what the operation done. So node n link will be equal to n, that is the x will be there, and then last node's link will be equal to node n. Next operation we have is deletion. So again deletion is done at the beginning, at the middle and at the end. So I want to delete this particular node for beginning, the first node I want to delete. So how can I do it? Any guesses? So we can just make the start to point, instead of pointing to first node, I can make it to point to node A directly. That means this will not be removed from the memory, but there will be no link between the start and the first node. So that means it is removed, that is removed from the list of elements. So this is how it is happening. So I will be removing the link, that is the start will have the address of node A, that is the node A, and now the node A will be the first node. So this is the operation what we have to do for deleting a node. Next we want to delete the node B, which is at the middle. I want to do the operation of deletion at the middle. So how can I do this? Again what we are going to do is, instead of that node A is having a link of node B, so instead of having this node B's link, I am going to have the link of the last node. So what is there in this link, that has to be copied here. That means this particular node B will be removed. So that is what I have given here. So the address what is there in node B of link will be stored here, so that it is directly pointing to the last node. The next one operation what we have is deletion at the end. So I want to delete, it's very quite simple over here. What we are going to do is, we are going to have this x end pointer to be there in the last but one node, to tell that the last node is not removed and only this is treated as the last node. So that is what I have given here. Next, the next operation we have is traversing, visiting, that is what is called as traversing from the first node till the last node. So we want to perform this traversing for the purpose of deletion, inserting an element, and where it has to be done, that we have to find. For that we can use this traversing, and even for identifying, for searching we can use it. And to finding an element will return two values. It will return the position of the element if the element is found. If it is not having that particular element to be searched, then it will return a null value. So we can implement, actually this is the next part we have with linked list, implementation. So the implementation can be done in many languages. So here I have concentrated on C++. So if you want to do implementation of this linked list concept in using C++, then we need to define this node concept in the terms of structure, where it has two elements called as data and a link part, and the link will be done using pointers. Now we have the application of links. So whenever we take any data structure, we have to know what is its application. So we have this polynomial addition is an application of linked list. What is polynomial addition? I have polynomial equations. I want to perform the addition of these two equations. Say for example, I have a of x is equal 5x squared plus 9x plus 2, and we have b of x which is 9x cubed plus 9x plus 5. So here we have these two polynomial expressions where the exponent, that is the exponent of both the things are not same in the initial state. That is, say for example, here it is x squared and here it is x cubed. So it has to compare and it has to find which is the greater one, and it has to add the similar exponent values only. So what it does is, it is used in there is in the linked list we have this polynomial addition where it has three parts. That is, the linked list the node is divided into three parts. There is the coefficient part, the exponent part and the link part. So we have these three things. So how it is performed is, actually, so we will be getting the value. So it will be first taking the 9x cube, and then it will take here in the a of x, it will have check whether it is having a cube exponent 3 x3. So it is not having that. So what it will do take the 9x cube as it is and have it in the result one, and then next it will take the 5x squared, which is the higher exponent, and it will compare with the b whether it is having an x squared component. So it is not having that, so the coefficient of 5x squared will be taken as it is and it will be inserted in the result. Next one, we have here the component x1, we have here also in a of x and also in the b of x. So it adds both the values, so 9x plus x, which will be 10x, and the coefficient x power 0 was here we have in the a of x also as 2 and in b of x we have 5. So what happens is it will add these two values, so 2 plus 5 we have it as 7. So this is how it is performed. So that is what I have given here. So if the exponent are same, then add the coefficients of both the terms and store the result in the result polynomial. Move to the next node of both the polynomial because we have added both the coefficients. If the coefficient of b is larger than the exponent of a, then store the coefficient and exponent of b to the resultant polynomial and move to the next node of b, only the b polynomial and the result polynomial. If the exponent value of a is larger than the exponent value of b, then store the coefficients and exponents of a and the result polynomial. Now we are going to see about the types of linked list: singly linked list, doubly linked list, circular linked list and circular doubly linked list. So we will see one by one. So this is singly linked list. So this will have, as we have seen in the examples, so we will be having a start node which will be pointing to this, and the node will be dividing into two parts, that is the data part and the link part. When we go for doubly linked list, the initial node will also have a link to the previous node, and it will also have the link to the next node. So it has two links, that is called as the left link and the right link. So we have both the links and it will be pointing to the the left link will be pointing to the previous node and the right link will be pointing to the next node. This is called as the circular linked list, where we can travel from the last node again to the first node. So the last node's link will be not x, it will be having it as, it will be pointing to the first node. So we can travel back again to the first node. So traversing here is not only once, it can be many times. And the last one is the circular doubly linked list, which is a combination of both circular and doubly linked list, where it has two parts, that each node will be having two parts, the left link and the right link, and all the left link will be pointing to the previous node. So the first node will be having the address of the last node, and the last node's right link will be having the address of the first node. So the traversing can be done in any direction. It can be traveled from first to last or from last to first. So it's possible for traversing in any direction. Thank you.